Hi everybody. We ran out of time to go over review assignment number 9 today, so I'm going to do it in this video. And just a reminder, and this I'm only going to focus on number 2 since number 1 was basically you finding different scenarios for things. But for this one, we're basically making a fan go slower by turning it from high to low, and we're diagramming that interaction. So before I get started, I'm actually going to look at our lesson that this was attached to, lesson 6. And it turns out that we have a very similar situation in this question that is asking about a fan system. Only the fan in this case is operating at its maximum speed and its operating temperature. But it still is going to give us some clues about how to set up the whole energy diagram framework. And the thing that probably should be added to review assignment number 9 is let's make it similar to this, and let's assume that it's operating off of a dry cell battery. Okay, so we said doesn't really matter for our task in review assignment 9 because really A, B, and D are going to give us the same kinds of clues about how to set up our framework. So we could use any of the 3 of them just to give us some clues about what the interacting objects are. But B for this question is the correct answer. So you'll see that we've got the dry cell battery. It's decreasing in chemical potential energy. And it's making the fan motor increase, or it's powering the fan motor, but it's also interacting with the surroundings to increase their thermal energy. And then the fan motor is pushing around the air, but it's also interacting with its surroundings to increase in thermal energy. So let's go back to our review assignment here. And I'm going to go ahead and diagram this energy diagram the same way that I did, or that I saw at least in that lesson. So I'm just going to start by putting all of the objects in there. So this is the battery, and it's going to power the fan motor system. Okay, and then that's going, and I'm going to fill in all the energy stuff later. And that's going to push around the air. Okay, so this is a good start, but don't forget that whenever you have an electric circuit interaction, you're also interacting with the surroundings to heat them up. So that battery is hotter than the surrounding air, so it's going to heat up the surrounding air. And that fan motor, especially the motor part, is hotter than the surrounding air, so it's going to interact with the surrounding air or other surroundings. Okay, it's supposed to be SURR for surroundings. All right, so then we need to figure out what kinds of energy are in each bubble and if they're increasing or decreasing. Let's start with the battery. So the battery is basically a chemical reaction that is powering the fan motor system. And even though we have turned it to low, the fan is still on. So that means it still must be powered by the battery, which means that the battery is using up its chemical reactions. It's being depleted, however you want to think about it. Okay, so we're going to have it decreasing in chemical potential energy. Because whenever you have chemical reactions that are responsible for some kind of energy input or output, that's chemical potential energy, okay? Now the fan motor system, that's the trickiest part. We have to look carefully at this problem, or this question and what it's asking. It's saying that the fan immediately begins to slow down. So what does that tell us? That means that it must be decreasing in kinetic energy. The fan blades are what we're describing here, okay? Now you can think about this as a result of the battery, the fan motor system would be increasing in kinetic energy because the battery is powering the fan motor system. But as a result of the interaction with the air, it's decreasing in kinetic energy by pushing around the air. And it just so happens that in this case, the fan motor system air interaction is winning out over the battery fan motor system interaction. And if you want to, you can kind of put a little tiny little increase in kinetic energy there, and remind yourself, well, that's from the battery that's powering it. That's making it, would be, if there was no air interacting with it, it would be increasing the fan motor speed. But because of this interaction with the air, it's actually decreasing in kinetic energy. And so as a result, the air is being pushed around by those fan blades and increasing in kinetic energy. So you might think the air must be cooling down because that's the fan's purpose, is to cool down a room. But it does that by pushing around air and basically making wind. It doesn't do that by decreasing the thermal energy of the air. So it's a little bit tricky. Okay. So let's go back and let's think about the surroundings. The battery is warmer than the surrounding air because it's been operating for a while. And so as a result, it's going to warm up the air around it. And so we've got increase in thermal energy of the surroundings. And then also the fan motor system is going to be, because of these electric circuit interactions, warmer than the surrounding air, and therefore increase in thermal energy as well. Okay, so let's go back then and label the types of interactions. Let's start with the battery fan motor system. Well, that's an electric circuit interaction because it involves basically an electric circuit with all of these components. Okay, so electric circuit. And then the fan motor system is basically pushing around the air. So those are little tiny collisions with air molecules, between air molecules and the fan blades. So that's going to be a contact push-pull interaction between the fan motor system and the air. And then between the battery and the surroundings, and then the fan motor system and the surroundings, again, those are starting with the situation of two things at different starting temperatures. The battery's warmer than the surroundings. The fan motor system is warmer than the surroundings. And so that is your clue that these are heat interactions. Now, I didn't write energy in those little arrows, but you get the picture, you know to do that. This is basically the type of energy diagram that would describe the situation here. Okay, when you look at EM Lesson 7, one of the summarizing questions is going to ask you another fan question, and so you can use the same framework to describe that question. Then you would be thinking about the main thing that you would be thinking about actually would be what is happening here. That's the thing that's usually different from between questions. Is the fan speeding up? Is it slowing down? Is it operating at a constant speed? Okay, so that's what you really want to be paying attention to. If the fan's on, it's always going to be increasing the air's kinetic energy. If the battery and fan motor are operating, they're always going to be warmer than their surroundings, etc. The only other thing to pay attention to is we are assuming here that the battery and the fan motor system are at their operating temperatures and therefore not increasing in thermal energy. But if you're thinking about just the beginning of an interaction where you just turn on the fan and the battery is warming up and the fan motor system is warming up, then you would have an increase in thermal energy in both of those places here. It's not very explicit in this review assignment number 9. So if you did put an increase in thermal energy, that's fine. But I'm assuming because it's been running on high for a while and you just turned it down, that it's operating at its operating temperatures. So that's the only other thing to pay attention to there. So there you have it, review assignment number 9.